Welcome to the producer physics classes, and let's start with the 12th standard physics. And I divided this total syllabus into 15 chapters. 15 chapters, that is chapter 1, electric charges and fields, and the next one, chapter 2, is electrostatic potential and capacitance, and the chapter 3 is current electricity, that deals with the moving charge. First 1 and 2 chapters deals with charges at rest, and the chapter 4 is moving charges and magnetic fields. Then magnetism and matter. Chapter 6 is electromagnetic induction. 7 number chapter, alternating current. Then 8, electromagnetic waves. 9, ray optics and optical instruments. Then chapter 10 is wave optics. Then chapter 11 is dual nature of radiations, and chapter 12 is atoms. 13 nuclei. Then semiconductor devices and electronics, and the last one is communication system. So let's start with electrostatics. First of all, we have to know for electrostatics, we have to know electric charge. That we are familiar with the mass, that every matter consists of mass. Similarly, charge is the property. Associated with matter, due to which it produces and experiences electrical and magnetic fields. So let's start with electric charge. And from the fundamental of electrostatics, we know that there exist two types of electric charges, that is positive charge and negative charge. And the charges with the same electrical sign, this is the convention of charge. Every atoms consist of three fundamental particles, that is electron, proton and neutron. That is, proton is positive charge, and the negative one is electron, and the neutral, that is neutron particle, is the neutral charge particle. So charge with the same electrical sign repel each other, and charges with opposite electrical sign attract each other. Just have a look to my laptop, and that from the laptop you show the different figures are given there, and with the notes, so it will be easy for you. So electrostatics, electro means charge, and the static means rest. So when charge is at rest, the branch of physics that deals with the charge at rest is called electrostatic. Here the one number topic is electric charge, and the definition is here. Charge is the property associated with matter, due to which it produces and experiences electrical and magnetic effects. So charge is the intrinsic property. And suppose, give an example, like that two students, one of them is Ram and the other is Sam. So Ram has the property, Ram is a good boy, and the another boy, that is Sam is likes, he always in a casuist nature, that is he do something negative thoughts. So this is Ram or Sam, the two students, and their intrinsic property is positive. And similarly, there is positive or negative charge. It is only convention that positive charge can create a field, and negative charge is also create a field. But if we placed a test charge within the field of positive charge, then it repel, and the negative one is attract that particular positive test charge. So there exist two types of charges in nature, that is positive and negative. And the next one, here it is shown that if the two positive charges are there, then they repel each other, and when the dissimilarities between the charges, that is one is positive and the another is negative, then they attract each other. So this is the basic and fundamental property. So charge is a physical quantity that can be measured, and it is a scalar quantity. So its unit, SI unit of charge is coulomb, and coulomb is a huge amount of charge, that is equal to 6.25 into 10 to the power 18 number of electrons can gather 1 coulomb charge. And so it has a submultiples like that: 1 millicoulomb, milli means 10 to the power minus 3 coulomb, 1 microcoulomb 10 to the minus 6 coulomb, and nanocoulomb, nano means 10 to the power of minus 9 coulomb. And its CGS unit is ESU, that is electrostatic unit. It is 1 coulomb equal to 3 into 10 to the power 9 ESU. So when you converted these into CGS or SI units, then, and this is the relations: 1 coulomb equal to 3 into 10 to the power 9 ESU. And the dimensional quantity Q is dimensional. From the dimension we know that there are 7 fundamental and there are 2 supplementary physical quantity, and the 7 fundamental physical quantities are mass, length, time, temperature, current, electricity. Current, electricity is the fundamental, but charge is not fundamental. And then luminous flux and the amount of substance. So here current I equals to Q by T, that is we know from the 10th standard, I equal to Q by T, that is the rate of flow of charge. So charge equal to current into time, and current is denoted by I or A, that is A into T is the dimension of charge. So next topic is point charge, and from for the clearance of this point, what is point charge? Suppose you met an Italian or African friends in the airport, and he says, where are you come from? Then you say that I am an Indian. So with respect to the universe, India is a point. But when Indian says where you come from, then you have to say the particular state, that is West Bengal. Here with respect to the Indian, and West Bengal is the point. And similarly, if you from Durgapur, then Durgapur is the point with respect to West Bengal, and so on. As such, I am from Konishko, so Konishko within Durgapur, Durgapur within West Bengal, and so on. So point with respect to everything is relative, and whose spatial size is negligible as compared to other distances. So point charge whose spatial size is negligible as compared to other distances. And the properties of charge: charge is a scalar quantity, and it is added or subtracted algebraically that you have to consider as positive or negative. And the charge is transferable. The charge cannot be created, not be destroyed, and it can transfer. If a body is rubbed with another body, then the less work function get less work function, more it requires less energy and get positively charged, and the greater the work function, it get negatively charged, and it mass increases slightly according to the mass of electrons. That is 9.1 into 10 to the power minus 31 kg. Mass of electron equal to 9.1 into 10 to the minus 31 kg. And the number of electron transferred is equal to, if 10 million electron is transferred from one body to another, then the mass increases with 10 million into 9.1 into 10 to the power minus 31. So the next topic is the properties of charge, and charge is always associated. Let's zoom in for clear view. It's okay. Charge is charge is always associated with mass. That is, charge cannot exist without mass, though mass can exist without charge. And charge is the conservative property, and charge can neither be created nor be destroyed. And the invariance of charge, the numerical value of an elementary charge, is independent of velocity. Though mass is dependent of velocity, according to special theory of relativity, we know that if a mass is moving with approximation of the speed of light, then its mass variant according to the equations m equals to m naught by root under of v square minus c square. So next equations, in the comparisons, here it is given, the equations is given here, m equal to m naught by root under of 1 minus v square by c square. So we have to compare the charge and mass. It is the next topic. So invariance of charge, the numerical value of an elementary charge is independent of velocity, and the charge produces electrical and magnetic field. Charge can produces electrical and magnetic field. The fourth number chapter is moving charge, and moving charge can create magnetic field also. In this chapter we can discuss with the electric field, that is, it can produces electrical fields and natures. And charge resides on the surface of conductor. The next one is charge resides on, you can stop the video and note down the notes given here. So charge resides on the surface of conductor. Charge resides on the surface, as for example, if a soap bubble is taken and giving a charge, then the soap bubble expands on charging. So that's it means that charge always resides on the outer surface of the conductor. The next one is the very important properties of charge. There is quantization of charge. When a physical quantity can have only discrete values rather than any value. Suppose you have given your father a 100 rupee note, that is, it consists of 100 into 1 rupee. That is, here 1 is the quantum. 1 is the quantum. So 100 rupees means 100 into 1 rupee. That is 100 times. So 1, 1, 1, and the total is 100. So 100 is 100. Similarly, here Q equals to NE means N. Here 100 is equal to N, and the E means the least value of electronic charge, and here the value is given minus 1.6 into 10 to the power minus 19 coulomb. So Q equals to plus minus of NE. Here N is the natural number. You have taken 1, 2, 3 and so on. And charge on a body can never be 0.5 e. What is 0.5 e? That is the fractional value of electron, which is not possible. Though for the next time we can show you that charge can be divisible. That is quarks in form of quarks, 2/3 of E or 1/3 of E, up and down quarks. So in this chapter you have to know that charge cannot be divisible, and charge on a body can never be 0.5 or plus minus of 17.2 or and so on and different. So if some questions is given that is this possible, 0.5 electron is possible or not, then straight cut you have to write down that this is not possible. So the next one is comparison of charge, and the next one is comparison of charge and mass. It's so simple. An electric charge can be positive, negative or zero, but mass of a body is the positive quantity. Always it is positive, and charge carried by a body doesn't depend upon the velocity of body. Charge is always remains, it is the intrinsic property, and charge remains constant though its velocity increases. But when the velocity is increases, the mass doesn't remain constant according to this special theory of relativity. There is mass equals to and m naught is the rest mass, and when the mass is moving and this velocity is comparable with the velocity of speed of light, then m equals to m naught by root under of 1 minus v square by c square, where c is the velocity of light in vacuum and m is the mass of the velocity, mass, and v is the velocity, and m naught is the rest mass of the body. So the next comparison was charge is quantized. As we know, Q equal to NE. that is charge, always resides in the integral multiple of least value of electronic charge, that is 1.6 into 10 to the power minus 19. This is the least value. So charge is quantized, but the quantization of mass is yet not to be established. Electric charge is always conserved in nature. The mass is not conserved, that is, it is changed into energy equal to mc square. We know that equal to mc square. So force between charges can be attractive or repulsive, but the gravitational force F equal to g into m1 m2 by r square, we know that the gravitational force between two masses is always attractive in nature. So the next one is the methods of charging. The methods of charging a body. A body can be charged by the following methods. What is charge? It is the frictional electricity. So by friction we can charge a body. In friction, when two bodies are rubbed together and electrons are transferred from one body to another, as a result of this, one body becomes positively charged while the other is negatively charged. So here a basic common concepts is work function. Work function means the minimum energy required to emit the electron from the outermost shell. So the work function, here suppose there is the two, one is charged and the another is uncharged sphere here, and if we rub together, then the less work function get positively charged, and the work function which is more than that of the other body is negatively charged. So by friction we can charge a body, and however ebonite or there is an electrostatic series, there are numbers, and if we rub together with the as you've seen in the books, your NCERT books or any other books, so there is electrostatic series, there is the arrangement of different substance, and if we rub together with one and another, the former one is positively charged and the latter one is negatively charged. So for example, clouds also become charged by friction. In charging by friction, in accordance with the conservation of charge, both positive and negative charges in equal amounts appear simultaneously due to the transfer of charges from one body to another. And the next process, by if you want to charge a body, the next important process is by electrostatic induction. Induction is a method if a charged body is brought near an uncharged body. So this is charged body, means there exists excess amount of charge, that is positive, and here a body that is neutral in the sense it has positive charges as well as negative charges. So here the positively charged body attract the negative charge particles, that is, this is called bound charge, and this one which is away from the charged body is called free charge. So if we earth the surfaces, so if we earth this one, then it is this charges flow because it is free charge, but this one is bound charge, so the sphere is negatively charged. So if we separate this, if we away from this charged body, then the charge are uniformly distributed over here, and this process is called the whole process, that is shown in 4 steps. One, you have to, first of all, you have to bring a charged body near an uncharged body or neutral body. Then the second step is it is earth and the charged body is away from the uncharged body. So and then this is, and if you want to charge this body positively charged, then you have to bring a body of negatively charged. So this is the process of induction. By induction method, if a charged body is brought near an uncharged body, the charged body will attract opposite charge and repel similar charge present in the uncharged body. And as a result of this, one side of the neutral body closer to the charge, That's closer to the body is becomes oppositely charged, and while the other similarly charged, and this process is called electromagnetic. So if you if there is a questions, what is the electrostatic induction, then you have to write down this one. If a charged body is brought near an uncharged body, and then this one, and this is the process is called electrostatic induction. So the next one is the another process, that is there are three processes actually: by friction method, by induction method, and then charging by conduction. Take two conductors, one charged, another is uncharged, and bring the conductors in contact with each other. The charged, whether the negative or positive, under its own repulsion will spread over both the charges, and this is the conductors will be charged with the same sign. This is called charging by conduction method. So conduction method is so simple method, and a charged body is just brought near the uncharged one and touch it. So the next one is this is electroscope here. So the next topic is electroscope. Electroscope is a simple apparatus with which we can check the presence of what type of the nature of charge. So first of all, this is a rod, and this one are the gold leaf, that is lightened leaf. And if we touch here the disc here, if we touch a charged body, that is positive charged body, then the charge goes through this rod and on the leaf, and we know that the equal charges repel each other, and this type of divergence occurs. So at this moment, this is positively charged, charging by conduction method. And this is also possible by charging by induction method. So in induction method, you have to just brought near these discs, and this is negatively charged. So the negative charge is here and the positive charge is here. So positive and positive repel each other, and the divergence takes place. And similarly, if you want to charge this one with negatively charged, then the negative charge is taken here. So if you want to negatively charge, the negative charge is taken here. If you want to positively charge, then positively charged body is taken here, and this one is touched with but grounded with a conducting wire. So this is electroscope, gold leaf electroscope, and the another picture is here. So if we revision all the topic here, that is in electrostatics, you have to know by familiar with electric charges, and there are two types of electric charges, positive and negative charges. What are the fundamental law of electrostatics? That is like charge repel each other, unlike charge attract each other. What is the unit of charge? That is coulomb, or dimensional formula is 80. The point charge, point is the negligible charges, whose spatial size is negligible as compared to other distances. The properties of charge is a scalar quantity, it is transferable, charge is conservative invariance, electric field creates an electric field. Charge resides on the outer surface, it is quantized, it is conserved. And then compare the charge and mass. Then what are the different process you can charge a body? What is the least value of electronic charges? That is least value of electronic charges is 1.6 into 10 to the power of minus 19 coulomb. and here it is given 1.6 into 10 to minus 19 coulomb, and the special formula related to this chapter is Q equals to Ne, that is charge is quantized. What is quantum? Quantized, that is charge is always the integral multiple of least value of electronic charge. Least value of electronic charge. It means that if we gather 2 coulomb charge, that is what is the number of electron you have together, that is Q equal to Ne. Here N equals to Q by E, that means 2 coulomb by 1.6 into 10 to the power minus 19. Then after dividing you can get a particular value, that this is the number of electron you have together. So the next one, let's start with the next chapter for the next day, Coulomb's law. This is the important features or importance. What is the attraction or repulsion, how much attraction force or repulsion forces takes place with the positive or negative charge. So let's for the next class, this one is Coulomb's law. Here it is completed the first chapter. That is the first chapter is completed, and this one is elementary phenomena of electrostatics. Let's see for the next day, Coulomb's law. Thank you.